manufacturing, technology, hot topics, and a little bit of tomfoolery. This is the MTD Podcast.
So welcome to today's podcast from MTDCNC. I'm joined by Gio Albanese and Mr. Joe Reynolds. A few topics on the agenda today. Gio, what's going to be the first?
So the first topic, firstly, good morning, Paul. Good morning, Joe. The first topic today is going to be additive manufacturing and its place in our marketplace. And is it going to take over, conventional, traditional fashions of machining components?
And then, Joe, topic number 2.
Yeah, good morning. On a similar theme, the fourth industrial revolution, Industry 4.0. Is it a myth? Is it here to stay? Or is it, just a name being given by some guy in Germany?
And then finally, and probably the most interesting one, we're going to talk about what we would do as individuals if we were to set up a machine shop, what we would purchase and how we would go about running that business. But that's coming up towards the end of the show today. Firstly, I've got to say, Joe, much better off camera than on.
Likewise, Mr. Jones. Likewise, I wasn't expecting that, but yeah, glass stones, no stones in glass houses, whatever they mean.
Well, we always like a little bit of banter along the way. And Gio, are you well these days?
I'm very well, thank you, Paul. And yeah, going back to that last comment, you can eat as much as you want on these podcasts.
There you go. Yeah, and 12 months you've been with us now. 12 months.
And you're still not putting on any weight.
I don't know. I have put a little bit of timber on, to be fair.
And I'm certainly a good example of that on these podcasts. You can eat as much as you want. Okay, right, so let's kick things off then. I'm interested, firstly, Gio, in your opinion. You've been with us, as Joe said, now 12 months, travelled many an engineering company over the past year, talking about Industry 4 and watching and seeing whether it's actually being implemented. What's your take on it? Is it going to be the change that manufacturing either needs or wants?
I mean, from my experience, I think Industry 4 to a certain degree has been with us for years now, but it's just not been made aware to us as it has been certainly over the last few years. So in regard to Industry 4, it's just all about information and gathering that information and being able to analyse that information and compare that information to help you become more efficient. So I think it's an information world that we're all living in, and it's just the next big thing, really. And I think we've touched upon improving machines through software, and it's part of that, really, using how far can you improve a machine to make it more efficient. It's very difficult to do that now, to get big gains from it anyway, for sure. So with Industry 4.0, we're looking, it's a different angle, really, to become more efficient, in my opinion.
And Joe, are you seeing many companies embrace it, though, or is it more of one of these topics that everyone keeps talking about, but no one's really got it by the neck?
Yeah, there's no mass adoption at all, is there? The interesting thing, people talk about Industry 4.0, I want to buy myself a robot or a pallet loader, which is the third, that's going back Henry Ford times almost, isn't it? That's going back to Industry 3. Industry 4, in a word, no. We all see it at trade shows, at open houses. It's a bit like my new car, actually. I've got loads of gimmicks. I'll probably only ever use 30% of those toys. And Industry 4.0 is exactly the same. There's probably 9 elements. And depending on what business you've got, you probably only need to adopt 2 or 3 of those elements.
I didn't know Robin Reliance were that advanced.
Yeah, they are, yeah. So it's just establishing what is right for your business. Servitization is right for one business, it's not to another. Equally, virtual reality will never be a thing.
For me, there's some aspects of it I don't really get, because if you take somebody like Matsuura, for example, they've been talking about the uptime on their machines for many, many years. It's been their biggest selling point. It's 97% uptime, 98% uptime. Surely that's Industry 4, isn't it? It's about making sure that you can collect the correct data to ensure that the machine is running for the majority of the time. That surely is Industry 4.
No, depending what you talk about, that is just productivity. Industry 4 would be, let's say your Matsuura is working 97% of the time, and you have a shutdown, which I wouldn't do, by the way, but a lot of companies still have shutdowns. So you've got a week there, you come back the following week, and your spindle's gone. Arguably,
but then it wouldn't be 97% uptime.
It would have been prior to it going down, wouldn't it? But if you can look on the screen, if you can look at the Internet of Things, is basically what sensors on the machine, so which is an element of Industry 4. So if you know that spindle needs service in so many hours, you'd do it on your week off.
You can plan for it.
You plan for it, predictive maintenance rather than reactive maintenance.
But all that comes round to the same thing, that spindle is going to continue to turn for 97 or 98. And I mean, I don't know whether a Matsura is 97, 98 or 99%, whatever it might be. But the reality is it still comes back to the fact that whatever the data is that Industry 4 is providing, you want to get that maximum uptime.
Yeah, well, it's preventive maintenance, like Joe mentioned. I think it's not just the maintenance that saying the spindle is going to blow up at a certain date, but say, for example, if you start seeing wear in that spindle, so then the spindle is not running as true as it was before, that will affect the quality of the component. So effectively, you'll be getting vibration within that spindle, which is causing vibration in the tool, which is reducing the tool life. So it's all about optimization of every kind of aspect of the process, isn't it?
Yeah, what you're talking about, Paul, is productivity. And the two, okay, you can argue that there might be a crossover, but like Gio says, it's about spindle uptime might be 97%, but your efficiency might be low because you're not running the tools how they're designed to run. You know, you got to sweat your assets, of course you have, but arguably, if that machine is running 97% of the time, and you can run the tools 20% quicker, you're not doing well, are you? It's because the spindle's turning. It could be going better.
Yeah, correct. No, you are right. I think my point being is that machine tool manufacturers, for example, have been looking at, you're right, productivity and uptime for a long time, which really is as well as what Industry 4 is about, isn't it? But it's just using methods around data collection.
It's nothing new, mate. I don't think it's anything new. The data's been collected for probably... Okay, with more sensors on machines, we are collecting more data, but people at home on machine tools, people have been collecting our data for the last 10 years.
Absolutely.
Industry 4.0 is about actually doing something and acting upon that data.
Absolutely. And I think another good point really is that, yeah, it does may lend itself to some organisations. However, you know, you go in some shops, how many shops do we travel in where there are a lot of machines that are not turning or the spindles are not moving because they're doing low volume work, so... why is it still relevant to these people? You know, I understand it and I can see it from the perspective, if you need that machine running 24/7, you need to know when it's going to break down, you need to know if there's a problem with that machine or what is causing a problem.
I mean, what about if you're a job shop? What about if you are you get a knock on the door, here's a component, you need to break the machine down, put the part on. Is it still relevant to you then?
Exactly, that's a good point.
Of course it is. Because we're going to come on to job shops at the end, but if you've given a one-off, you should be in a decent shop. You should be able to make a one-off for a similar price as a 2, 5, 10 off. Because if you've got a palletized machine, you can be setting that machine offline, programming offline, and you're just calling into a pallet into a cycle. Okay, you've got your cycle time divided by one part as opposed to numerous parts, but it shouldn't affect your efficiency because that machine should be running regardless.
But how is Industry 4 benefiting you? In that scenario,
well, it's all part of it because palletization and automation of machines is part of the Industry 4. But for me, then you're starting to talk about big investment. You know, for a job shop to start palletizing machine tools based on what they may or may not get through the door.
It depends. I'm not. Yeah, of course. A palletized horizontal or whatever palletized anything is more expensive up front than the standard machine without it. However, if you were to finance that, if you're the type of business which finances, it's not a lot of money. It's cheaper than having a human being stood there. Plus, it's running arguably 24/7 if you've got the right system or the right work. Henry Ford said improved productivity means humans should sweat less, not more. It's not about having a man stood there.
Why are you sweating then?
It's too hot in here.
but I think if you look at software like FactoryWiz, for example, now I've been quite engaged with FactoryWiz for many years now, and that software is becoming more and more popular. And certainly recently at the Dugard Open House, they had it on two fairly basic machines, machining centers, VMCs, and what it was doing is it was measuring, like you say, the amount of time that the machine wasn't actually cutting metal. It was looking at the tool efficiency. It was looking at everything from the tool changer to the amount of time that the man was spending on the machine. So that's a relatively low cost way of getting into this Industry 4. But to me, that's a good example of, I do think it is being adopted, but probably not as fast as some would hope it should be.
Yeah. Just on the FactoryWiz, and there's numerous other systems. that is an example where you just have to know what your machines are doing at what time of day, how you can schedule work. I don't know how you could run an efficient factory without. Okay, you don't necessarily need Internet of Things, cloud computing, but machine tool monitoring is an absolute given, in my opinion.
All onto a webcam. Every single machine on factory whiz that you have in a machine shop, MRT castings, for example, 60 odd machines all wired up to factory whiz. At any minute of the day, they can check the efficiency of that machine, what it's doing, what's coming next. Are they having more tool breakages than they should have? If so, what are the reasons behind it? Spindle wear maintenance.
And as I say, what you find the OEMs are doing it, there's Smart Factory from Mazak, and I'm sure all the other manufacturers have similar. But imagine if you could have a free product, you open source that software. I don't know how you would do it, but if you made that accessible to everybody and you monetized it elsewhere, could you imagine everyone would adopt it, wouldn't they?
Yeah, absolutely. I think that I totally agree with the points that have been risen. I think that a lot of people are still not embracing this technology, and I think that it is something that should be embraced in some circumstances. And I do factory whiz. I was at the Dugard Open House with you, Paul, and I was speaking to Mike, isn't it, about the product, and there are huge return of investments to be had, but you need to be proactive with that information. It's no good acquiring information and doing nothing with it, or you're not going to be getting any gains. So if you get the information, you need to do something with it. It's like a CRM system, if you like. It's as good as the information that you're putting in. And it's the same, but the other way around with Industry 4.0. If you don't do nothing with the information, your factory, your business is not going to get any gains.
Yeah, just a final point from me on that. I think if everybody clicked their fingers and adopt it, nobody would buy a machine tool for 12, 18 months because you don't need them. If you improve efficiencies to that nth degree, people say, I need a new machine, I'm busy. Well, how many hours a day is that VMC running? 30 at 20% efficiency.
I think that's an interesting point because you can apply that to so many aspects of machining as well. For example, like even down to your work holding, if you're more efficient with the amount of parts you can put on the table, you might not have to buy that second machine. Okay, I know you've got a second spindle, but you might not have to buy that second machine. So it is about rethinking. Do you still think you're learning about Industry 4, or do you think you've learned as much as there pretty much is to
I'm learning every single day about every single aspect of engineering. There's not a day that goes by where I don't learn, and I'm definitely not an expert in Industry 4 in any way, shape or form. This is just an opinion that I have from the information that I've gathered. I think some experts don't really know what Industry 4.0 is.
You're making a lot of money, Gio.
What about how many people, if you took 100 companies, and I know it's quite a broad thing, Industry 4, how many do you think are actually, in some way, shape or form, actually tapping into this Industry 4
I think
buzz?
I'd say 100 companies out of 100 companies are probably somewhere along the lines are using Industry 4, but probably don't even know that they're using it.
Yeah.
So people that are actually using it and know that they're using it, I'd say is a very low percentage.
You visit different companies to me, Gio, because I can tell you it's the opposite. I would think 1 in 10 would be using Industry 4. It would be my opinion.
Yeah, and I would say even less.
What I'm saying is, in every single shop floor, there is Industry 4 technology. It's been around for years and years and years, but it's only been made aware to us of what it actually is, and they've put a name on it. And I agree that it's very less the people that are actually using it because they know what it is, if that makes sense. Does that make sense?
I think in every county, there's probably 2 companies that are really up to speed on it and making a good fist of it.
More in Shropshire. They're really clever in Shropshire.
That's because they need to be.
But yeah, there's things about
nothing else going for it. Other than a bit of farming and agriculture.
keep food on your plate, Mr. Jones. Keep
cattle
food on
grids
your
on
plate.
the road.
But just
Broke
going
my
back
high
onto
heels,
Industry 4, if you don't mind, before I turn your mic off. It's do you know what? I've really lost my train of thought now. Oh no, I know I'm going with this. It's a big part of Industry 4 is augmented reality, and obviously we're only just getting started, both commercially and from an industrial perspective. That's going to have a massive impact on manufacturing. Where's it going to go? We don't know, do we? But will you be able to just look at a part with your goggles and it knows it's this size hole and that sends it to the CNC control, or you haven't got a 10mm drill, you have to use an end mill?
I'll give you an example, a big example of this I've just picked up on, which we'll be looking at the Herco Open House, is the Herco's WinMax control is it's a hugely popular piece of software on the machine. They're just developing their own CAM system in the software, which basically means you can import a model straight into the control. There's no need for a third-party CAM software solution.
Is that your opinion?
Well, that's the opinion of those that have obviously produced this control, and they wouldn't do it for any other reason other than to give their users the option of using a complete Herco product. So that is something we'll look at in due course, but it's really a way of a machine tool manufacturer saying that, let's make it really easy for you. Just get your model, import it, and it'll write the program and machine it.
But I think this is going to
needless to say, there are a few things within the CAM within that software. They've already said Herco that aren't quite as powerful as a CAM system, but who knows where it will lead.
I think that it will lead. I think that kind of leads us on to another subject where it comes to additive manufacturing. I think that in regards to OEMs making their own products, I've always kind of been a bit baffled to a certain degree why they haven't actually. They're still using some third-party equipment on their product, and why they haven't incorporated it into their own product, because obviously it can be bespoke to their particular product and work in harmony with it. But in regards to the simplification of processes and making components and so on and so forth, that's where in our next subject I'd like to touch upon in additive manufacturing. That additive manufacturing, I was when I was on the shop floor, from my own experience, I never thought that it would take off. I thought it was impossible to take off. But now looking at process development, if you've got a 6-opt component, on an additive manufactured machine, you're doing it in one operation. You've got a stable process. Nothing can go wrong effectively, and it's simplified the manufacture of that component. And if I was to, and leading on to the third subject we'll touch on in a bit, but if I was to set up if I was a young kid looking to set up an engineering shop, I think the first piece of equipment I'd buy is a 3D printer.
Would you? Because you see, let's start that second topic now. I think we've done to death the Industry 4, but the additive manufacturing side for me, I still see it less so than Industry 4. People talking about it, people showing it off, people bringing new products under their portfolio, or 3D printers, but still. How many machine shops are we going in? How many manufacturers are we going in where they have bureaus, where they have 3D printing technology?
Not enough is the answer.
Not enough. But is there a reason for that?
Yeah, I think it's education. The trouble with 3D printers, okay, it can be a £500 unit, or it can be a £500,000, £1 million additive manufacturing system. I would have one tomorrow if I had a machine shop. I would be printing my chuck jaws. I would be printing and my vice jaws. All my CMM fixtures, they would all be printed. Actual components, probably not yet, but it's not far away.
But surely it's going to be cheaper for you to buy your chuck jaws than print them.
No, I disagree. No, because how long does it take to put chuck jaws in, bore them out, get them to size? You probably 15 minutes, 20 minutes.
I don't know. I don't think it'd be as long as that.
Well, step jaws, 2 or 3 diameters. You got to put them in. Whereas you go home, you print one, you come out. All you got to do is put them in. 66p a minute.
I'm not sure if I don't know if that. For me, I don't know if that's the right example. However, I still think that additive manufacturing is still in its infancy. I still think it's a product that's still evolving, and I don't think it's at the finish line yet. And I think it's certainly a technology that is moving at a tremendous speed, and I think it's a technology that everyone should be looking to embrace, because for me, what the power of additive manufacturing is say, for example, you're looking to make any product, whether that be aerospace product, whether that be a art product, a sculpture, whatever that product is. It's de-skilling engineering completely. So you could be a kid that's just come out of school with no engineering experience, buy a 3D printer and make things. Yeah, that's impossible before.
Printing's the easy bit. The issue you have is parts aren't... if you get a component, 9 times out of 10 it'll be cheaper to machine than additive manufacture. When we talk 3D printing, let's just talk about metals.
And I think that's the case with your chuck jaws.
If they're made out of metal, I'd agree with you, but they don't need to be metal.
But fair enough.
It certainly suffices. Certainly from a milling application where you've got to put a profile into it, you're looking about between £5 and £8 to do it as some sort of Kevlar material, or you buy two aluminium ones. Obviously, you've got you've got to fit them, which you would do to the plastic ones anyway. But then you've got to take up valuable machining time. Comes back to machine optimization and what have you. You know, but it's
the same with cutting tools as well.
You only want to be using that machine tool to make you money, not cost you money.
But it's the same with cutting tools. We're seeing some manufacturers. One that jumps in my mind is Mapao, printing cutting tools, aren't they? And that comes into a little bit into Industry 4 as well. But it just shows that these companies are looking at, you know, ways of advancing themselves and putting themselves in front of the crowd with them. But again, are people buying those tools? Are people making their own chuck drawers? And if they're not, is it down to education, or is it down to the fact that actually it's not really reality, Joe?
Yeah, sometimes engineers were 10 years behind the curve, whether we like it or not. You know, I've been doing this 25 years. I'm learning every day, so we're always behind the curve. But
Since you were 30.
I genuinely feel you're good at putting me off. You are really. No, I would be doing that, but it's down to education. Engineers, if you're not sure, the default setting is it's better the devil you know, isn't it? That's how I've always done it. How many times have we heard that? You know, when I used to come up with ideas, and I was even going back when I was an apprentice before machines were invented, before April. You know, you come up with an idea. Oh no, we've always done it like that. Yeah, so you've always done it wrong, probably. You know, if you're using the same strategy for more than 3 or 4 years, you're doing it wrong. You just are. And it's the same with technology. It's the same with machine tools, printing, cutting tools. It just is. You need to be adopting this technology in one shape or form, whether it's as a CMM fixture, whether it is as a chuck, whether it not a chuck, sorry, a vice jaws, or even chuck jaws. You've got to use it. In terms of 3D printed parts, that won't go mainstream until designers change how they design parts.
I agree with you, certain aspects of that. I think work holding in general, I think there's a big marketplace for 3D printing, especially more for me. In my opinion, chuck jaws is too basic of a product to put on a 3D printer. I like it, and I would use it or embrace it to do real complex fixturing. You know, 3D fixturing of a mated part that needs to sit on it, for example, where you couldn't hold it in any other way. CMM fixturing. So
why wouldn't you do it? Just out of interest,
for jaws,
£1,000 printer. Why wouldn't you do vice?
Because
jaws?
I think that, say for example, if I needed to make, if I was a job shop and I were making soft jaws, if it was for 1-offs, 2-offs, stuff like that, I'd need the jaws really quickly. And I think that it'd take too long to do them on a 3D printer because I'd be waiting for them to be printed, but I could just machine them.
Poor planning, Gio. Would you not print them overnight and they're sat there waiting for you the following morning?
Sometimes you need to be reactive and it needs to be there and then. You haven't got that luxury of being able to pre-plan something that's coming through the door. And I think in a scenario like that, I would probably look to just quickly machine the jaws out, you know, have soft jaws. But I definitely think there's a place for very complex fixturing, absolutely. I think that there's value in it there, but also lots of different areas as well in regards to the manufacturing of components to get a stable process, because you're eliminating potential errors that can occur in a process of actually machining it.
That's what I think the case that Joe makes is the 3D printing is so vast. You can start at the low end with just a plastic printer and maybe do some of the sort of applications that Joe's talking. But when I look at 3D printing and additive manufacturing now, I am thinking more of the Lumex machine or the Sodic machine, which are actually doing the printing of metals but also machining them as well. Yeah. And I think that this is an area for me which I do think has really got legs, in the sense that you can change the way, you know, we go back to a part that was at the recent TCT show, the Trumpf component, which was like a part from a boiler which was printed, and the way it was redesigned and re-engineered was to get that component to be the most efficient in its working environment at the lowest possible cost, and you couldn't do it as efficiently or as effective any other way than 3D printing it. And that was 3D printing metals. Taking it onto the next level, when you then start to machine parts as well, I really see that to me is definitely the future of additive manufacturing, albeit it's a big cost to get involved in. But it is, like you say, Joe, it's the rethinking and the re-engineering. So you've got two aspects to me. You've got the simple end. Okay, can you buy a machine and print your chuck jaws and print your work holding and print your other bits and pieces? And if you can, what's the potential saving really? Is it big enough to warrant it? Yeah, then there's the other end where you go, right, you know, this really is the future. This is additive manufacturing.
Yeah, the two are complete polar opposites almost. I know it's the same topic. JJ Churchill's, they now print their CMM fixtures and also their components. But what they're doing is they're obviously doing components for a well-known engine manufacturer. Excuse me. And basically, it used to take them 40 minutes to set up a fixture, get the component, probe the component, basically set up a CMM program. Whereas now they print the end component. Okay, ultimately it goes in the bin, but it saves them 40 minutes on the CMM. Equally, it saves them thousands of pounds every time they get fixtures made, and more importantly, it saves them a lot of time.
Yeah, I think that the opportunities and the potential is endless, and I think that a lot of people have not even thought of what that they can actually do with it yet. And I think that, again, ultimately, it depends on what work people are doing to how that technology can help them.
You can print anything. You know, we see this day in, day out. People telling us we can print this material, we can print this part that goes on an aircraft, we can print this part that goes in a Formula One car. It's a bit like, you know, Joe or yourself, Gio, on the football pitch doing keepy uppies and volleys in the back of the net, but can you score those goals when you really need to? And I think that's the biggest part. No, I'm not so sure. I think it's whether these products can actually be used for the applications that they're designed for. And certainly with aircraft parts, critical components, people talk about it, but I don't see many in programs.
I wouldn't disagree, and that is without question the biggest barrier to entry of premium additive manufacturing or hybrid machines. It's when somebody ticks a box and says yes, and I believe some materials are aerospace approved, I believe, with a caveat, I'm not 100% sure, but I believe they are. And as soon as somebody ticks a box and says this aeroplane, this engine is made of 100% or 50 or 20% additive manufactured parts, it's not going to take off, if you excuse the pun, in the aerospace sector. But you know what? It might in automotive. I know if you look at McLaren, if you look at the SVR, Range Rovers, they will have additive. Well, they've got printed parts on now, where volumes aren't as attractive, and it is easier to take weight out because it's a performance car. We don't want a brake hub or brake caliper that's solid. We want one that's 80% honeycomb because it's going to save X amount of weight. And that will happen. In fact, that is happening.
I totally agree with you, Joe. I think that especially in the aerospace industry, where I had experience myself, where you say, for example, you've got critical parts that come in a casting form. The castings have got variants, so no casting is exactly the same. So when you come in to actually manufacture that casting, the work holding was an absolute nightmare because you couldn't hold it the same every time, and the first operation was so complex. And also you'd get a lot of scrap due to this because of trying to hold the part because of the casting variants there. You know, until you'd actually done the first operation, you haven't got a stable process. But if you were to 3D print it to a kind of casting stage, then you know that every kind of to that form it's going to be exactly the same, and it gives you a stable process to then make the part from, if you can get the composite of materials right.
And if they did that, Gio, would you get on a plane?
I still wouldn't get on a plane.
Crazy fool. On that point, then let's move on then to our final topic on today's podcast. If we were to set up a machine shop, probably taking into account a lot of the things we've discussed, what would we do? Where would we start? Joe?
Do you know what I'm looking forward to? I wish you'd come to me last, though, because I get some good ideas from you guys. Do you know what? Obviously, it's difficult. It's easy to say I'd have this machine and that machine, but if we had an open checkbook, I know exactly what it would look like. But in short, I would want palletized machines, probably horizontals. Everyone talks about the aspirations of adopting 5-axis technology. I think quite often that's unfounded. You'd be better off with palletized horizontal machine. You certainly go to America, countries like this, even around Europe, you see a lot more horizontals than you do in the UK. And I think that's a mistake. I would probably have palletized horizontals. Yeah, why not? Let's have a 5-axis as well. But I think you get far more efficiency. And most jobs, it's 2 ops regardless of the machine, and 99% of the jobs. So you may as well do it on a horizontal than a vertical. I'd have sliding head technology. I would have multi-spindle, multi-turret machines, all expensive ones really, but the theme throughout would be automation. And I don't necessarily mean big fast stem systems and huge pallets. It could be as simple as having a machine with a trunnion where I can load 20 parts, and that just happens to take 20 hours or 3 hours, and you just have to load it. You know, automation in its most basic sense. Obviously, the aspiration is to get to these large ones. What I see, the people driving the Bentleys and the Ferraris, they automate low volumes where the price isn't that great because it's low volume, but they make
high value.
High value. Automating high value, low volume components is where the money is. Of course, you can automate high volume, but typically, you know, that's either gone overseas, although it's being reshored, which is great. But the money is in automating low volumes, and I think it's fairly straightforward. Okay, there's a ticket price to be paid for the benefit of those machines, but I think that's where the money is. And also, I'd be vending my cutting tools. I would have, without question, I'd be if I ever saw a guy program on a machine, I'd want to know why. And yeah, factory whiz, all the good stuff.
It's quite interesting, isn't it? Because what you're talking about is a utopia, and I think we would all probably follow a similar path. You don't often find companies that are like that struggling, and that's probably what would put you in that position where you would choose maybe those options, because there are a few companies certainly that I visited recently on both ends of the scale, ones that haven't invested initially in technology and still refuse to, and still look at what the list price of the machine is rather than what they can get off of it. That's all too common. And the second one is where you see companies that have invested in the pallet systems, the horizontals, the 5-axis, the multi-pallet machines, the multi-spindle machines, the sliding heads, and like you say, whether they may be driving very nice cars and making very good livings. So there's obviously an argument to suggest that's the right way forward. But there is also one company that we visited recently, which kind of would throw into the mix. And Gio, you knows these, or this guy. I can't remember the exact company name, but actually where he makes most of his money is on the quick turnaround, simple parts on his manual machines where nobody else wants to touch. Now I can't remember the name of that company.
Downhurst Engineering.
Downhurst Engineering.
I wasn't even there, but I know. But yeah, I know the company well.
Really interesting conversation. A guy that does have technology as well. He does have Mazak turning centres amongst other machines. But when you ask him, it's whether he's running his business right or wrong. When you ask him actually where he makes most of his money and is able to keep his maintain price points, is doing those types of work. And that's really because others don't want it. And everyone is focused on this, right? These volumes, or look at that sexy component. I want to machine that nice prismatic part on a 5-axis machine. Well, when I come to do that and I put my quote in, I'm actually quoting against 50, 60, 100 other precision engineering companies. Whereas there is the other part of the jigsaw where you can actually maybe look for niche markets and say, okay, I'm not going to get too involved in that because I can probably make more profit, keep more control of the customer by doing parts that maybe aren't quite so sexy.
So in short, you're going to have a little shed full of manual lathes and turtles. Industry 4.5.
What I should have said at the start of this is I'm not interested. I don't want to set up a machine shop. I'd rather do this. What I think is I agree wholeheartedly with you, Joe, and I think for me, it is very easy for us to sit here and say, yeah, I'd have one of these, and I'd have a Matsuura MAM 72 and a DMG Mori 5-axis machine, a Nakamura lathe, twin turret, and all the rest of it. But I actually would strive for those things because I think you have to. But I do think also you can't be too short-sighted to think that really is where you are going to A, have the most success, and B, make the most profit. Because let's not forget the fact that skill shortages are a big thing, and you still need skills in engineering, and those skills are often.
I think the biggest issue, and I'm not saying it's right, I'm not saying it's wrong, is the culture. How many companies buy a machine to go to market to fill that capacity? I don't know the answer, but I bet you it's not more than 25%. People buy a machine to add because they're busy. You go to China, you go to the States, you go to some parts in Europe even, they're thinking, I'm going to buy that machine and I'm going to fill it. Whereas over here, it's very seldom I hear that, Gio.
And that's exactly the same as the scenario of SW Machine Tools when we were at AMB. Is it Rainer?
Rainer Fries, yeah.
Rainer Fries was telling me that they sell their machines around Europe or into the UK when the customer is bursting at the seams and needs that machine. Then they buy it, Whereas in China, they buy the machine and then they fill it. It's a different mentality. Yeah, I know it's very easy to say we'll go out and buy a £500,000 machine, but is it a £500,000 machine, or is it a machine that can make X amount of components in X amount of hours, which can turn into a profit?
I think it's really good points. I think that I certainly agree that you don't really, and the engineers listening to this will probably hate me for this, but you rarely see an engineer or go to an engineering company where they've got old cars outside. Engineers are doing well. It's a profitable market to be in, and good on them, because they deserve it. I mean, I visited plenty of engineering shops over the years, and one of the first questions I ask people when I go in there is, are you busy? And the people that say, yeah, we're really busy, we're doing really well, they take you on the shop floor and they've invested in new technology. When someone says to, more likely than not, when someone says they're not busy and they're quiet, you walk around the shop floor and you don't see no new technology. They've been doing stuff the same as they've been doing it for years and years and years, and they're getting left behind. If we were to, or I was to start up an engineering shop myself, it would all be dependent on the product I was making in regards, or what I wanted to make in regards to the machines I'd be looking to buy. However, I totally agree with you guys. I'd be looking to invest in the latest technology, because if you don't invest in the latest technology, you're not going to be able to be competitive. And we visited a company recently, an aerospace company recently, where they're looking to optimize the process, automate the process. Now, with aerospace work, it's medium volume, low volume, that repeats every single month, and they want to automate that. And now the problem with automating it is to get that process absolutely perfect, because it's quite a complex part. There are a lot of things that can go wrong with that part. But once they've got the process absolutely nailed down to a T, they're looking to automate it, and that will take them to the next level. One, it'll be making more profitable. Two, they can start winning work from abroad. But three, that they can start giving their customer a better price on the part. And it's a win-win-win scenario for not only the company, but for UK manufacturing. And I think it's technology and embracing that technology.
So if I had to say you can pick one machine, and we don't necessarily have to mention a brand. One machine, you don't really know, you haven't won the work yet.
What's my budget?
Well, your budget really is, that's a good question. I mean, I would say forget the budget. You've got one machine, but what you need to do, it's not about the outlay, it's about what that machine can make you. You've got one model of machine that you think you could put into your building as your first machine tool and actually get your business off the ground. What would it be?
I'll start, and I'll go for an horizontal, like Joe mentioned, and the reasons being is that we've seen a big, massive rise in fifth axis machines. Now, a lot of people are buying simultaneous fifth axis machines, and they've never needed to do a full fifth axis part. Now, Joe made an absolutely fantastic point in regards to horizontals. Most things get done in two operations. Now, with a horizontal, say even if I'd start probably with a twin pallet horizontal, it gives you so much flexibility. If you're doing low volume work, you can do it. If you're doing high volume work, that you can do it. And you can do all of your components, even if they're six-sided parts, in two operations. And each pallet, you don't have to stop, because you can be doing, say if you've got a four-sided column, on each side of that column you could be doing different batch work, and on the other pallet you could be doing different batch work again, or the same batch work per face. And the opportunity and the flexibility is endless, and the profit in it is phenomenal. Now I just want to say, with the fifth axis, in some scenarios people are running fifth axis work which should be done on an horizontal.
But bear this in mind, you're going to have to pay for this machine. Let's not talk about the outlay, but you're going to have to make sure you can get the work in to be able to cover the costs of that machine. So you'd still pick that as your...
Absolutely, because I think that it wouldn't take long. It opens itself up to lots of different parts that you can make on there, whether it be low volume, high volume, medium volume. I think that you'd have to be specific in the kind of work that you're looking to win, but I think that it gives you the most flexibility to do pretty much any kind of milling work that you want to do.
Joe?
I think we're all going to say the same, aren't we? A palletized horizontal 4-axis machine with the B-axes, or high-level multitasking done in one type, turn mill turn, call it what you will. I guess the advantage of having a lathe is the fact you can make turn parts, and essentially with some of these parts that come off sliding heads, for instance, you couldn't tell if it's been done on a mill or a lathe. So there's an argument to suggest go down for a turn mill or mill turn rather than a horizontal. But I suppose if I had to go one way, I'd palletized horizontal.
See, I think one of the machines that I would consider would be a gantry load twin spindle lathe with milling function, based on the fact that probably the outlay is going to be, okay, it's not going to be cheap, but I believe that with that type of machine I could do bar work, I could do billets as well if I had load and unload features. So it would give me more flexibility. I could also do milling, especially if I had a Y-axis on that machine. So it would mean that I could get into volume work, or maybe if the volume work wasn't there, I'd still be able to use that machine unmanned. And the outlay of that type of machine is going to be less than a multi-function.
I'm spending the money. You can't take it with you.
That's a good point, actually, Paul.
Or sliding head. But my worry with the sliding head would be
capacity.
It would be more to the fact that there's a lot of them out there, and there's a lot of people that have been using sliding head lathes and manufacturing components on them. They've squeezed every cent out of their cycle times. Can I compete in that area without the right knowledge and without a quantity of machines to be able to increase the quantity of parts? Twin spindle gantry loading lathes for bigger diameter parts, chucking operations. There's certainly less of them in the market. My competition is less, and the outlay. Yeah,
I would always assume though that particular kind of machine would be for if you were making your own product, and it's like that kind of machine lends itself quite well to the automotive industry. If you're making the same parts, billet parts for higher volume, I've always assumed that would be for that. But I suppose there are aspects of flexibility within that machine where you could even put a bar feeder on it, and you could even have, so you could double up and kind of. I always used an analogy that if you were using a mill turn machine, you added a bar feeder to it with 80 mil capacity. If you did medium volume aerospace work, prismatic work, as long as that square fitted within the circle of an 80 mil circle, you could be milling them all and parting them off, and then just change your program and use the same bar, because the price of the material will be
shop, because we've got all these great ideas. Gio's got all the money. Albanese Enterprises set up a machine. We could have gantry load over there, horizontal over there, and do you know what? I will go for the sliding head after all.
So there you have it. That would be our combined machine shop. Well, I hope you've enjoyed this podcast, guys, gentlemen. It's been a pleasure talking to you this morning,
Paul.
and look forward to the next one.
See you later.
Bye bye.